Hi, hello, dear students. Welcome to my class on mole concept. This is a topic mole concept. In this topic, there are different sessions I will going to discuss in this class. That is measuring matter, one session, and mass and moles of compounds, empirical and molecular formula of hydrates. Okay, this I will do it. It is the first one. In this, the major objectives in this session are how a mole is used to indirectly count the number of particles of matter. Another one, how the mole is to be common everyday count unit. Converting the moles, the number of representative particles. In the review of the vocabulary, we have molecules is nothing but two or more atoms that covalently bonded together to form unit. That is a molecule. New vocabulary, we will call it as mole Avogadro number. So what is the main idea in this one is chemists use the mole to count atoms, molecules, ions and formula units. Counting particles. As we all know that chemist needs a convenient method for accurately counting the number of atoms, molecules or formula units of substance. Not only chemists, everybody interested to know what is the accurate number of atoms or molecules or units in a substance. We need this knowledge. So what is that one? The mole. The mole is the SI basic unit used to measure the amount of substance. And as you know, this 1 mole is the amount of atoms in 12 grams of pure carbon 12 isotope or 6.02 into 10 to the power of 23 atoms. And this number only we will call it as Avogadro's number. Come to the point, what is the conversion concept? That means moles into particles, how we can convert it. That means the conversion of moles into particles, conversion factor is nothing but Avogadro number 6.02 into 10 to the power 23 particles per mole. Suppose if they are given number of molecules, if they ask the number of molecules in 3.5 moles of sucrose, what is the meaning of this one is the conversion factor for this one is moles into molecules is multiplying this value moles with the Avogadro number. So if you do that one, you will get 2.11 into 10 to the power 24 molecules of sucrose in 3.5 moles of sucrose given to us. Now, particles to moles. How can we convert the particles into the moles? That also we will check it off. In this discussion, when we have done the one thing that is earlier, what we did is we just multiplied with the 6.022 in 10 to the power 23. Now we have to take the inversion, that means reciprocal of the Avogadro number. So when you want to convert the particles into moles, then you have to take the reciprocal of the Avogadro number with the particles given in the question. Already we have found the particles in the sucrose is 2.1 10 to the power 24. If that particles are divided with Avogadro number, we will again get 3.5 moles of sucrose. So the problem is very clear for us. First what we did is we have taken a 3.5 moles of sucrose and converted that into particles, molecules. Then after we converted the particles into moles by taking the reciprocal of the inverse of the Avogadro number. So use the inverse of Avogadro number as the conversion factor to make the particle number into moles. Now, another assessment will check it off. What does the mole measure? As now we observed, mass of substance, amount of substance, volume of gas, density of gas. Just now we observed that substance is measured using mole. Next, what is the conversion factor for determining number of moles of substance from a known number of particles. So when we have number of moles is there, to convert that into number of particles, what we'll do, we will multiply the moles with the Avogadro number. So Avogadro number is 6.02 in 10 to the power 23 particles is there. So that is the one inversion we will take it, because what is the conversion factor for determining number of moles of a substance from known number of particles? So we have converted the particles into moles. Here see, use the inverse of Avogadro number as the conversion factor for converting particles into moles. That's why here in this question, the B option is the right option for this question. Next one. Mass and mole. In the second session of this one is the first object in the session is the mass of an atom to the mass of mole of atoms. The second one is how to convert the number of moles to the mass of an element. And another objective in this session we will learn about the conversion of number of moles into number of atoms or elements of an element. In this vocabulary, conversion factor, that means the ratio of equivalent volumes used to express the same quantity in different units. New vocabulary is molar mass. So a mole always contains the same number of particles. However, moles of different substances have different masses. So moles of different substances have different masses. What you understand here is 1 mole of a substance glucose. If you take 1 mole of substance of urea, if you take, then what is the difference in this? Number of particles is same, but masses of 1 mole of glucose and mass of 1 mole of sucrose will be different. The meaning of this one is moles of different substances have different masses. Meaning is moles may be same, but masses of the different substances containing having same moles is different. Now here the mass of mole, 1 mole of a copper if you take, or 1 mole of a carbon have different masses are there. Just now we discussed about glucose and sucrose. Now here we are providing 1 mole of copper and 1 mole of carbon are the different masses are there. Then 1 copper atom has different mass than 1 carbon atom. Because here what will happen, you understand one thing in this one is 1 copper atom has a different mass than 1 carbon atom. Because of that 1 mole of copper and 1 mole of carbon have different masses. The mass of a mole, that means molar mass is the mass in grams of 1 mole of any substance. What is the meaning of this one is if you find the mass of 1 mole of substance, that you can call it as molar mass. Now if you observe here, the molar mass of any element, if you take numerically equal to its atomic mass and has units grams per mole. So 1 mole of iron is there. If you take an element case, iron is an element. In that 1 mole of iron element, we have Avogadro number of atoms of iron is there. Now moles to mass. Number of moles into mass in grams will give the mass of the substance. So if they provide the number of moles in the question, we can convert that one into mass. That is, if you see 3 moles of copper is given to us, then 3 moles of copper will be multiplied with its mass in grams is 63.546. We'll get 191 grams of copper. That means 1 mole of copper is 63.546 grams. That is molar mass. And 3 moles of copper will be the 191 grams of copper. So 3 moles of copper has the mass of how much? 191 is the answer for this one. Now, another important discussion here is convert the mass to moles with inverse molar mass conversion factor. What is inverse molar mass conversion factor is nothing but you have to take inverse of the molar mass. When you convert the mass into moles, so they will give mass in the problem, you will convert that mass into moles by dividing with the molar mass of that one. For example, convert the moles to atoms with Avogadro number as the conversion factor, then how you will understand this point here is nothing but to convert moles into atoms with Avogadro number as the conversion factor. So when you have the moles converting into atoms, then you just take the Avogadro number as the conversion factor. Now, if you see this figure shows the steps to complete the conversion between the mass and atoms. So in this figure in the middle, what you observed is 1 by number of grams. Okay, that is mass can be calculated. Avogadro number of particles by mole. Number of grams can be converted into moles by taking 1 by Avogadro number. So here, what is the inversion and conversion of the moles into particles and mass into number of moles? The conversion of mass into atoms now we are observing in the first picture. And the second picture you are converting the mass into number of particles. See here. What is second one is convert the moles into atoms. The first thing is moles, mass into moles. So that only we observed in this picture, mass into moles in the first picture, and the second picture converting the mass into atoms. Okay. Okay, we will understand using a problem now. The mass in grams of 1 mole of any pure substance. Mass in grams of 1 mole of any pure substance. What is that? 1 mole of any pure substance is there. Mass of that one is nothing but molar mass. That is molar mass. Next one we'll see. That is molar mass is used to convert. Molar mass is used to convert mass, moles into mass. Moles into mass. Molar mass is used to convert moles into mass. That's what we have done a problem also. That is the second session. Now see the third session, moles of compounds. In this session, you will recognize the mole relationship shown by a chemical formula, and also you will calculate the molar mass of a compound, and also you can understand the conversion between the number of moles and mass of a compound, and you will apply the conversion factors to determine the number of atoms or ions in a known mass of a compound. In this review of vocabulary, representative particles, that means an atom, molecule, formula unit or ion will be used. Now, what is the main idea in this session is the molar mass of a compound can be calculated by its chemical formula, and it can be converted from mass to moles that compound of that compound. So this is the main idea in this one. For example, chemical formulas indicates the number and types of atoms contained in 1 unit of compound. So chemical formulas indicate the numbers and types of atoms contained in 1 unit of compound. So how can I understand this one is, if you take 1 mole of CCl2F2 that contains 1 mole of carbon atoms, 2 moles of chlorine atoms and 2 moles of fluorine atoms. So what is the meaning of the first paragraph is, chemical formula indicate numbers and types of atoms indicated in 1 unit of a compound. So chlorine is different, fluorine is different, carbon is different, and in the formula what is the number given in the subscript, that number is the number of moles of that atoms in 1 mole of the compound. Now molar mass of compounds. So molar mass of compound is generally equal to the molar mass of each element multiplied by moles of that element in a chemical formula and added together. So how you'll understand is the molar mass of compound demonstrates the law of conservation of mass. So once again, if you observe, molar mass of compound is equal to the molar mass of each element multiplied by the moles of that element in the chemical formula added together. So molar mass of compound usually demonstrating from the law of conservation of mass. Now how you will convert the moles of compound to mass? For elements, the conversion factor is molar mass of compound. The procedure is the same for compounds except that you must first calculate the molar mass of the compound. That means here converting the moles into compounds to moles of a compound to mass can be done using this method. Conversion factor is the inverse of the molar mass of the compound. For example, 5.5 grams of a compound is given. Molar mass is 185. Then how many moles is there? 0.0297 moles of the compound obtained here. That is one thing. Number of particles. Convert mass to moles of a compound with the inverse of the molar mass. That means convert moles to particles with Avogadro number. If you see this figure, summarizes the conversion between mass, moles and particles. So this you can understand from the previous discussion. Now we'll see problem to understand how many moles of OH- ions are in 2.5 moles of calcium hydroxide. So how many moles of OH- ions in 2.5 moles of calcium hydroxide? You want to find the number of moles of OH- ions present in 2.5 moles of calcium hydroxide means in the given formula 1 mole of calcium hydroxide contains how many? 2 moles of OH- ions. So 2.5 moles contains how many? You multiply it, then you will get 5. 2 into 2.5. Next question. How many particles of magnesium are in 10 moles of magnesium bromide? How many particles of magnesium are present in 10 moles of magnesium bromide? See, in the given magnesium bromide 1 mole, we have 1 mole of magnesium that contains Avogadro number of particles. But if you raise that one to 10 times, then you will get 10 power 24 of into 26.02. So second one. Next. We'll see the next session. That session is empirical and molecular formula. In the session 4, the objective in the session 4 is it will explain what is the meaning of percent composition of a compound. And also in this session, determining the empirical molecular formula of a compound from molar mass percentage and actual mass data. So what is the review vocabulary? That is percent by mass. That means ratio of mass of each element to the total mass of the compound expressed as actually mass percentage. What is the new vocabulary? Is percentage composition, empirical formula, molecular formula. So main idea in this one is a molecular formula of the compound is the whole number multiple of its empirical formula. It's the simplest formula. Molecular formula of a compound is whole number multiples of its empirical formula. So empirical formula, if you know, you can find the molecular formula. So first we will discuss about the percent composition. Then after empirical formula, after that molecular formula in this session. So see what is the percentage composition. So percent by mass of any element in a compound usually found by dividing the mass of element by mass of the compound multiplying by 100. So mass of element by mass of compound into 100. For example, if you take urea, You want to find the percent mass of nitrogen in urea, then what will do? Mass of nitrogen by mass of the compound into 100 you will take to find the nitrogen percentage. So the percent composition of mass of each element in a compound is percent composition of the compound. So what is this one is? Percentage of by mass of each element in a compound is called as percent composition of the compound. So what is the point here discussed? Percent by mass of element is the formula is shown. Here percent by mass of each element in a compound is percentage composition of the compound. Same definition. So percent composition of a compound can be determined from its chemical formula. So how will you find a percent composition of a compound that can be determined by chemical formula? See, percent by mass. Mass of an element in 1 mole of compound by molar mass of the compound into 100. So percent by mass you can calculate using this formula. Now, what do you mean by empirical formula? Empirical formula of a compound is the smallest whole number mole ratio of elements is known as empirical formula. Okay, so it's the simplest ratio of the elements in a given compound. You can calculate the empirical formula of percent by mass assuming you have 100 grams of compound. See, it's very easy to convenient way to understand if you take 100 grams of compound. That's why convert the mass of each element into moles, then you can get the mass of each element. The empirical formula may not be same as that of molecular formula, but it may be same in a case where percent compositions obtained by dividing their atomic masses with the masses with the atomic masses. Molar formula of hydrogen peroxide, if you take H2O2. So here empirical formula of hydrogen peroxide is HO. So empirical formula of hydrogen peroxide is HO. How came? That is simplest formula. Now it's a molecular formula specifies the actual number of atoms of each element in one molecule or formula unit of a substance. What is molecular formula? It tells about the actual number of atoms of each element present in one molecule or formula unit of the substance. Molecular formula is always whole number multiple of the empirical formula. Another important thing to understand what is molecular formula. It is always a whole number multiple of empirical formula. So in this paragraph, if you observe this flow chart, first you can express the percent by mass in grams, percent composition, mass of component of elements, and finding the number of moles of each element. How you will do it? Mass of each element by molar mass. Then you can find the number of moles of each element. Then ratio of moles of each elements you can find. Examine the ratio, mole ratio. If all the whole numbers are there, then it is called as empirical formula. If not all the whole numbers are there, then multiply the smallest factor that will produce the whole number. So that means if you got the two numbers, after dividing the mass of element by mass of molar mass, then what you will do is in the two numbers, which number is small number, with that you will divide all the numbers. After that you can find the empirical formula, then you can tell the experimental molecular mass by mass of empirical formula will give the n factor. The n factor will be taken to multiply empirical formula to get the molecular formula. Now we will see what is the empirical formula of the compound C6H12O6. So whole number is not there. So 612 is there. If you take the ratio, 612 ratio is 1:2:1. So 1:2:1 is 1 carbon, 2 hydrogen and 1 oxygen. Simplest ratio is 1:2:1. So that is matches with the third one. Next one. What is the empirical formula of hydrogen peroxide? Just now we observed hydrogen peroxide empirical formula is HO. Next session, we will see next session. There is a formula of hydrates. Formula of hydrates. In this, objectives of this session is explaining what a hydrate is and relate the name of hydrate to its composition. Determine the formula of hydrate from the laboratory data and crystal lattice informations, three-dimensional geometric arrangement of particles. The new vocabulary is hydrate, and hydrates are nothing but solid ionic compounds in which water molecules are trapped. That is the main idea, is the formation of hydrates. Now we'll see the naming of hydrates. A hydrate is a compound that has a specific number of water molecules bound to its atoms. That means one water molecule may be there with the ionic compound, or two are there, three are there. Depending on the number, you can put the name of the hydrates. So number of water molecules associated to each formula unit is compound is written usually with a dot here. So between sodium carbonate and water, 10 waters, so we are putting dot. So sodium carbonate, 10 waters means 10 means deca, so 10 decahydrates. Sodium carbonate, decahydrate. Likewise, we have list of formula of hydrates are there. Ammonium oxalate monohydrate, calcium chloride dihydrate, sodium acetate trihydrate, and iron ferric phosphate tetrahydrate, copper sulfate pentahydrate, cobalt chloride hexahydrate, magnesium sulfate heptahydrate, barium hydroxide octahydrate, and sodium carbonate decahydrate is there. So examples there. Now analyzing hydrate. When heated, what happens? Water molecules are released from hydrate, leaving anhydrous compound. So this is a general example experiment you will do in the lab to understand the given salt is the hydrated salt or not. That can be easily understand after heating the given salt. Inside the walls of the test tube, there will be some water droplets will be developed that indicates the given salt is hydrated salt in the salt analysis. So that is a simple example. To determine the form of hydrate, find the number of moles of water associated with 1 mole of hydrate. So how to determine the formula of hydrate is find the number of moles of water associated with 1 mole of hydrate. So how many water molecules associated with 1 mole of hydrate, that we have to first calculate it. Weigh hydrate, you have to weigh the hydrate and heat to drive off the water. That means completely water leaves, then you can understand the compound mass. So before heating, you have to weigh the hydrate. After heating, you have to weigh the hydrate without water molecules. Then after, if you find the differences, the difference is number of moles of water only. So the ratio of number of moles of anhydrous compound to the number of moles of water to the moles of anhydrous compound will become the coefficient of the water in the hydrate in the given hydrate to us. So what are the uses of hydrates? Anhydrous forms of hydrates are often used to absorb water. Suppose if you take calcium chloride, anhydrous calcium chloride, used as a good dehydrating agent, particularly during the shipment of electronic and optical equipments. These are very important. In chemistry labs, anhydrous forms of hydrates used to remove moisture from the air and keep other substances dry. That is chemistry lab importance. Heating hydrate causes what to happen? Just now we observed when you heat the hydrate, what will happen? The hydrate containing water molecules are completely removed from the given hydrate. Next, a hydrate that has been heated and the water driven off is called as. So when we remove it, then we will usually call it as anhydrous compound. Suppose when you are calling calcium chloride is anhydrous, aluminum chloride is anhydrous, calcium chloride is anhydrous, means you have removed the water from it. Water is driven off. Next, measuring of matter, that we will have a key concept is there in this one. First we'll check it out. The mole is a unit used to count the particles of matter indirectly. So 1 mole of a pure substance contains how many Avogadro number of particles. So it's a revising case only. So representative particles includes atoms, ions, molecules, Born units, electrons, and other smaller particles. Now 1 mole of carbon atom has mass exactly how many? 12 grams. Conversion factor written from Avogadro relationship can be used to convert the moles into number of particles. So mass in grams of 1 mole of any pure substance is now we'll call it as molar mass. That is what we discussed in this second session. Molar mass of an element is numerically equal to atomic mass. Molar mass of any substance is the mass in grams of Avogadro number of representative particles of the substance. Molar mass is used to convert from moles to mass. The inverse of molar mass is used to convert the mass to moles. That is what in the second session we have discussed. In third session, in this class, we have discussed about key concepts, moles of compounds. That is subscripts in chemical formula indicates how many moles of each element are present in 1 mole of the compound. Suppose carbon dioxide is given, so 1 mole of carbon dioxide, in that the 2 moles of oxygen is there, because subscript in the for the oxygen in that formula is 2. Molar mass of compound is calculated from the molar mass of all elements in the compound. So one compound molar mass you want to calculate means you have to find the molar masses of all elements in that one. Conversion factors based on the compound molar mass used to convert between moles and the molar mass of the compound. In the fourth session, we have discussed empirical and molecular formula, that the percentage by mass of an element first we have to calculate. Then after that percentage will be divided with the molar mass of the elements. After that we will get some subscripts of the empirical formula to get smallest whole number. That we will call it as empirical formula. So molecular formula, after the empirical formula only you can calculate the actual number of atoms of each element in a molecule, and formula unit of the substance can be drawn after that. So molecular formula is nothing but whole number multiple of empirical formula. And the 10th, in the fifth session, we have discussed about a formula of hydrates. The formula of hydrate consists of formula of ionic compounds and number of water molecules associated with the one formula unit. Number of hydrates consists of compound name and the water hydrates and the word hydrate with a prefix indicating number of water molecules in 1 mole of compound. Anhydrous compounds are nothing but they will be formed after we remove the water by heating. What does Avogadro number represent? So now once again this assessment of this chapter will check it off. What does Avogadro number represent? Number of atoms in 1 mole of element, number of molecules in 1 mole of compound, number of sodium ions in 1 mole of NaCl, all of the above. See, number of Na plus ions in 1 mole of NaCl is not that one. So we have very clear. So 1 mole of sodium contains how many sodium ions are there? That will be understand from the Avogadro number. Number of molecules in 1 mole of a compound, number of atoms in 1 mole of element will be the actual idea about the Avogadro number. The molar mass of an element is numerically equal to what? Molar mass of an element, one atomic mass unit, 1 mole, its atomic mass, its atomic number, its atomic mass. How many moles of hydrogen atoms are in 1 mole of H2O2? See, given formula is 1 mole, the subscript is 2. So remember, that is the answer for this one. What is empirical formula of Al2Br3? Al2Br3. See, the simplest ratio 2:3 is the whole number. Simplest ratio. So we'll go with that only. So here what happened? Empirical formula for Al2Br3, empirical molecular formula of Al2Br3 is same. Next, what is an ionic solid with trapped water molecules called? So ionic solids will trap water molecules from the atmosphere, you all know. After that, they will become hydrated. So we'll say they are hydrates. Now, two substances have the same percentage by mass composition, but very different properties. They must have same. See here, two substances have same percentage by mass of composition, but very different properties are there. Substances are different. They have same percentage by mass of composition. They must have same empirical formula. So two substances have same percentage by mass of composition is there. So that can be understand using empirical formula only, because empirical formula will be same, but they have different properties. For example, if you take acetylene, if you take benzene, their empirical formula is same. Next. How many moles of aluminum are in 2 moles of Al2Br3? Again, simple model. That means how many moles of aluminum are in 2 moles of Al2Br3. Actually, the given is 1 mole Al2Br3. We have 2 moles of aluminum is there. If you make it double, then you will get the answer. As it is 2 moles given. 1 mole is containing 2 moles of aluminum. 2 moles of aluminum bromide Al2Br3 gives 4 moles of aluminum. How many water molecules are associated with 3 moles of COCl2, 6H2O? See, if you only consider the cobalt chloride hexahydrate, 1 mole of cobalt chloride hexahydrate is having how many water molecules? 6 into Avogadro number. What is the 6 into Avogadro number? 6 into Avogadro number. So you got it, 36. Okay. So that 36 into 3, you do it. You will get 1.1 10 to the power of 25, because if you take this formula in the 1 mole of cobalt chloride, what will happen? 1 mole of cobalt chloride, we have 6 into 6.02 means 36.12 into 10 to the power of 23 water molecules are there. So that is multiplied with 3, you will get 108.36 exactly, approximately. It is taken as 1.1 into 10 to the power of 25, because 110 into 10 to the power of 23 is 1.1 into 10 to the power of 25. Next one. how many atoms of hydrogen are present in 3.5 moles of H2S? How many atoms of hydrogen are in 3.5 moles of H2S? See, they have given the 3.5 moles, means first you have to take the 3.5 moles, and what is the subscript of hydrogen present in the formula is 2, 3.5 into 2 into Avogadro number 6.02. If you take, then you will get 42.14 into that 10 power 23. So that can be written as 4.2 in 10 power of 24. Now, which is not correct formula for an ionic compound? See, ionic compound means it is having cations and anions. But if any one of like carbon dioxide is not giving such positively charged cations and negatively charged anions, then we will go with that one. So these are the things we observed. 1 mole of iron contains Avogadro number of atoms. This is one interesting picture given to us to understand number of atoms of iron. Like that, the conversion pictures, all the pictures we have shown in these slides. These are all the things we have discussed in this session. Hope you observed this formula of hydrates also during our discussion in this class. Thank you. We will come with the next level in the next class. Until, have a nice day. Thank you very much.